Today we will see some more problems. It's a 15 kilonewton per meter. It's 80. It's a 4 meters. It's a 0.4. It's a 1.5 meters. Okay. Everything is same here. Same here. See, now you can understand what is the difference between moment distribution and this method. Both are similar. You feel that you get similar. Okay. Just see what are the fixed end moments. Fixed end moments take A, B, C. MAB is what? WL square by 12. So what is that value? That value is minus 20. So MBA is what? Plus 20. Okay. No need of same formulas again and again by 100 of times. No need at all. MBC WAB square by 2. AB square by L square. Okay. No need at all. So if we take it, minus of W 0.5 1.5 whole square by 2 square, this is 1.5. okay, you will get it is a minus 22.5. MCB is you will get it's a plus 7.5. that's it, na? That's it. Okay, that's it. If now you see distribution factor, only one joint is there, only B. So B directly you can write it's BA is what? 4EI by, because it's a fixed end, 4EI by L is 4, it's a EI. BC same again, 4EI by, it's a 2, length is 2, na? 2, it's 2EI. So total 3EI. So what is that? It's a 1 by 3, it's a 2 by 3. These are the distribution factors. Rotation factors, just off, multiply with, so it's a 1 by 6, it's 1 by 3. okay, just now you can see, now you can observe what is that values. Minus 20 plus 20 minus 22.5 plus 7.5. okay, it's minus 1 by 6, it's minus 1 by 3, it's minus 2.5. okay, that's it, now fix some of the fixed end moments. We already know it. Once again I will write MAB, so don't write here because final calculations will come here. Rotation contribution is what? Rotation factor multiply with sum of the fixed end moments at joint and sum of the rotation contributions from far ends. That's it, now. Now you can see it's the only joint of B. Very simple. Only one time. So what is MBA? Rotation factor is 1 by minus 1 by 6 and sum of the fixed end moments is minus 2.5. Rotation contribution from the far ends, from far end is A is fixed 0, from the far end is C is also fixed, so nothing, no need at all, nothing, just it's a plus 0.416. next MBC rotation factor is 1 by 3, sum is 2.5. the far end is same for the joint of B, the far ends are C and A. It don't receive any rotation contribution from C to C and A because those two are fixed. So what is that value? This value is 0.8833. Okay, 0.833. That's it. That's enough. That's the end of the story. It's a 0.416. It's plus 0.833. It's a 0. It's a 0. So what is the final moment? Final moment is, now we can observe fixed end moment, own rotation contribution multiplied with 2 rotation contribution from the far end. Far end is 0.416. What is that value? That value is minus 19.58. So here you will come plus 20 plus 0.416 multiplied with 2. BA has far end is A. A has rotation contribution is 0. So what is that value? This value is 20.832. Here, so minus 22.5 plus 0.833 multiply with 2. Far end is C. BC has far end is C. C has a contribution of 0. What is this value? Minus 20.834. Here, its own is 7.5. Own rotation contribution is 0 and far end is 0.813. What is this value? 8.33. That's it. This is the end of the problem. Now you can see, just observe it. Just keenly observe it. Keenly observe it. What is this rotation contribution MBA? Just keenly observe it. MBA is the rotation contribution at B end towards A. So what? Just think it is at moment distribution method. Just think at moment distribution method. So the unbalanced moment plus 20 minus 20, 2.5 is the 2.5 is the unbalanced moment. The unbalanced moment is we settle it. Are understood? We just settle it. We apply a 2.5. It reaches to sum of. If you applied a 2.5 at the joint of B, so half is reaches to the A. Are understood? Half is reaches to the A. So that's exactly same thing here. Half is reaches to the same. So this is the half now 0.46. We taken as this is 2. Are understood? Just it is reaches to half. We applied here. It is the value you applied here. We applied here. Half is reaches to here. Same we applied here. Moment distribution. Half is reaches to here. Are understood? It's a 2. We taken as it's a 2. Half is reaches to the other end. And we don't apply it here because it's a fixed end. It's a no need of settled moment at that end. So we applied at 0. So there is no reaches to the NFB. So just understand, it's the same moment distribution method. It's the same as a moment distribution method. I understood? Sir, what is this? This value also see. Off. Rotation contribution off. We taken as just a same stiffness. This is a, if you taken just a, it's a distribution factor. It's unbalanced moment. But we take applied as off. Multiply with off. Why it is off, sir? So because we taken this is a 2 MA. Understood? Just we is taken as that is a 2 MA. That's why we just multiply with off. Previously it's a distribution factor multiply with unbalanced moment. So now we just multiply with off because we taken as that is a 2 MA. Are understood? Previously we just taken as a this. Previously we taken as a, what is that value? Where is it? It's just taken as 2 MA. That's why just we come as off. So if you keenly observe it, both are the same. Huh? That's it. That is my idea. That's my intention to understand it. Okay. So if you keenly observe it, both are the same. Everything is same. Okay. Don't try to remember our class or Nagish. Don't. Almost everything is same. We get the same answers, na? That's it. If I say this is the first, if I would prefer this is the first problem, you can't understand what is the rotational contribution from the far ends. That's why I prefer those problems at the first end. So that's why I give a second order, not a second order, second preference to this solve this problem. Okay, now you got the idea of what is a rotation contribution, what is this. So next problem I will solve. One end is one end is one end is one end is hinge. So next problem I will solve. Every model will solve some one problem. Okay. If you take this is 80, same problem, 1.5, it's a 15. Okay, same problem. No need of calculation of fixed end moments. I already said what is the fixed end moments. You already know this is minus 20, this is plus 20, this is minus 22.5, this is plus 7.5. Okay, these are the fixed end moments. So okay, fixed end moments. So already know distribution factors. Those are the distribution factors, and rotation factors are small change. Small change, how it is changed? So taken as a B, taken as a B. So BA is 4EI by L. So BC is what? BC is what? BC is a hinge end. So it will come 3EI by 2. So this is EA, this is 3 by 2. So total is what? Total what you will get? Total you will get 1 plus 2, 5 by 2. 1 plus 2, 5 by 2. That's it. So that's it. It's a 2 by 5. It's a 3 by 5. These are the distribution factors. Rotation factors. Rotation factors. So half multiply with 2 by 2, it's minus 1 by 5. That's it. Half 3 by 5, you will get minus 3 by 10. That's it. Those are the rotation factors. And also C also giant. Are understood? C also giant. Sir, not a giant, it's the end answer. So that's why you have to take care of only C. If you taken C, it has only one end. So the total stiffness goes to that end. So the distribution factor is what? The distribution factor is for the CB is 1 because there is no another giant, total taken by its only. So if it is 1, what is the rotation factor? Rotation factor is 1. That's it. That's it. Because it's not a joint, it's just one end. So you will directly take it as a minus, directly taken as 1. Okay, if it is connected with some CB, it's 1. If it is like something, it's a overhang, there is no load, it's taken as it's a free and it's a 0. Otherwise, if it is like this CD, there is no load, there is no stiffness, there is no support, it's taken as a free and it's 0. There is no stiffness. It has a stiffness of only by self weight, not by, if it taken as self weight is negligible, there is no stiffness if it is D is there. So it's just one end, the total end goes to the CP, it's taken as 1. The distribution is directly taken, total is by CB, it's taken as 1. We previously discussed. Okay, so that's it. Now you can take it as okay. Now just take it as no need at all. Okay, we'll see. It's a minus, what is that value? Minus 20 plus 20 minus 22.5 plus 7.5. Okay, plus 7.5. Rotation contribution is, what is this value? This is 2.5. Rotation contribution is what? Minus 1 by 5 minus 3 by 10. Okay, minus 3 by 10. Here it's minus 1 by 2. Just see it. Okay, just see it. fixed end moment. So now it goes to what is that first value? First cycle A B C MBA. MBA is what? MBA is what? So rotation factor is 1 by 5. Rotation factor is 1 by 5. Sum is minus 2.5. And far end is from A. From A is 0. From A is 0. From C also 0. Because now we didn't calculate it. Sir, it's also fixed. No, C is a hinge and it allows rotation. Understood? C is also a hinge and it allows rotation. That's why you will get something. But still now we didn't calculate it, taken as a 0. That's it. Still now we didn't calculate it, taken as a 0. So what is that value? 5 is 0.5. It's okay. 0.5. MBC same. Minus 3 by 10, 2.5. Far end from A to C 0. So what is that value? 2.5 multiply with 3. So 7.5. No, 0.75. 0.75. Okay. So now from the C giant, go to C giant CB. So what is the rotational control factor? 1.2. Sum of the fixed end moments is what? 7.5. And also if you see now it's a 0.5 hits 0.75 already calculated from BC. For the C giant, what are the forends? What are the forends? We don't take it, it's taken as a 7.5. Okay, that's it. What is the forend? For the C has a forend of only B because C is connected with B. Forend contribution is what? 0.75. Are understood? 0.75. That's it, na? 0.75. So connectivity 7.5, 0.75. Answer divided by 2. You will get 4.125. Okay, 4.125. See, 7.5, 0.75. You will get what is it? You will get 4.7.5. Okay, once again I will write 7.5 plus 0.75. Answer divided by 2. Yes, minus 4.125. You will get minus 4.125. That's the first cycle. That's it. It's the first cycle. Goes to second cycle. Go to second cycle. Second MBA. Again rotation factor. Sum of the fixed end moments. Rotation contribution from the far ends. Far ends is what? From A to 0. From C has a value of minus 4.125. C has minus 4.125. Are understood? So 4.125 plus 2.5. Answer divided by 5. You will get 1.325. So MCBC 3 by 10 minus 2.5. Same, these values don't change at all. Okay, because contribution from A and C. Okay, same thing once again. 2.5 plus 4.125. Answer multiply with 3. 1.987. Okay, same goes to C joint CB minus 1 by 2. It's a 7.5. Now far end contribution is, now you can see it's a 1.325, 1.987. So far end contribution for C is 1.987. We already calculated, so use it. 1.987. So okay, 1.987 plus 7.5. Answer divided by 2. You will get 4.74. 4.74. Okay, so next we will go to start cycle. Third cycle, again MBA 1 by 5, 2.5. Foreign contribution is 4.74 now. Okay, now 4.74 minus. Okay, it's a minus. 2.5 plus 4.74, answer divided by 5 will get 1.448. Okay, 1.448. MBC same, 3 by 10, 2.5 minus 4.74. 4.74 plus 2.5, answer multiply with 3, it's a 2.17. So MCB, you will get 7.5. Foreign contribution is now 2.7. 2.17. Okay, 2.17 plus 7.5, answer divided by 2, you will get 4.85. Okay, so I will write 1.448. Okay, 2.17 here, it's a 4.85. We will see next, because the change is high level now. So we will see fourth cycle also. That's MBA 1 by 5, 2.5, 2.5. So foreign contribution is 4.85. Understood? 4.85. 4.85. 2.5 plus 4.85, answer divided by 5, you will get 1.47. Is okay. MBC 3 by 10, it's a 2.5. 4.85. 4.85 plus 2.5, answer multiply with 3, it's a 2.2. Okay, MCB is 2, 7.5, it's now it's a 2.2. 7.5, 2.2, answer divided by 2, it's a 4.85. Okay, 4.85. So 1.47, 2.2, so 4.85. See, these are the values are converged. So now it's end, don't take it. Okay, now it's end, we calculated. So now we can find out the final end moments. So final moments, so this thing, so final moment you can easily calculate it. What is this value? Minus 20, its own rotational contribution is 0. Far end is 1.47. 1.47, what will come? 1.47 is 18.53 minus here, plus its own contribution is 1.47. 1.47 multiplied with 2, plus 20, plus 20, 1.47 multiplied with 2, foreign contribution is 0, you will get 22.94. Here also you can see its own contribution is 2.22. 2.2 multiplied with 2, 4.4. 4.4, foreign contribution is 4.85. 4.85, so minus, everything is minus, you will get as everything is minus. Minus, so see, answer minus 4.85. Answer minus 22.5, you will get 22.95. 22.95, you will get same. Okay, so now this moment, it's, if you see what is this moment at C, no need to calculate, because C is a hinge joint, you will get 0. C is a hinge joint, you will get 0. Otherwise just check it is. 7.5 plus, so 2 multiply with minus of 4.85. Okay, that's it. So 4.85 multiply with 2, and foreign contribution is 2.2. 2.2 plus 2.2, you will get exactly 0. Okay, you will get exactly 0. Just I did problem, we got exactly 0. That's it now. That's the end. But the same problem, by the moment distribution method, we all just we reduce the kinematic indeterminacy. We reduce the kinematic indeterminacy, and also moment distribution method also we reduce the iterations. What we will do, we can easily do by this problem very easily. So I can do that only, but by the understanding of yours I did this much length. So if you see, the same problem is what, by the same problem, wait, by the same problem, it's what, it's a hinge joint. It's what, 7.5. That's it, na, plus 7.5. What is this, minus 20, it's a plus 20, it's a minus 22.5. What are the rotational contributions? Minus 1 point rotation factors, minus 1.5, 1 by 5, minus 3 by 10. So you don't want to take the, it is a extra kinematic indeterminacy, na? So you already know in displacement methods, if the kinematic indeterminacy is increasing, the iterations are increasing to find out the unknowns as increasing. So we can easily do, so what we'll do, we already know what you know, it is a hinge moment, it is a hinge joint, the final end moment is goes to 0. Final end moment is goes to 0, you already know it. So for that you have to apply minus 7.5 here. If you applied a minus 7.5 here, it's, you already know it's a 0, so it's going to be 0. If you applied a 7.5 here, half will goes to the, half will goes to the near end. That's it now, half will goes to the near end. So what is the half? So half is 7.552. What is that value? So exactly what is this summation value? What is this value? 7.5 divided by 2, answer plus 22.5, you will get 26.25. That's it, na? So now you can do problem. So you can just eliminate the C. You can just eliminate the C, degrees of freedom. You can just eliminate the iteration at the C level. Directly it's a plus 20, you can take it as 26.25. You already know the far end receives half of the moment. That's it, na? Just do it. If it is what now, it's a 6.25. It's just 6.25, na? That's it. It's just a 6.25. Now we can do only one iteration. That's enough, na? Only one iteration. Just see. So what is MAB? See, MBA is what? Just one iteration. MBA is directly, it's a 1 by 5 minus 6.25. What is that value? 6.25 divided by 5, you will get 1.25 plus MBC minus 3 by 10, sum of the fixed end moments is 6.25. Rotation contribution from far end, A is 0, C also just delete it. Okay, just delete it. What is that value? 6.25 multiplied with 3, you will get 1.85. 1.875. That's it. It's a 1.25, it's a 1.875. That's it. No need of anything. Just now we can just collect it. It's a minus 20, its 1 is 0, it's 1.25 far end. So what is that value? 21.25. That's it, na? Previously we got, what is that value? So sorry, it's a minus, it's a plus. 20 minus 1.25, you will get 18.75. What you will get? Same thing, na? Almost same. Almost same. No need it. It's all, these are all empirical, not a, so not an exact. Okay, so what is that value? 18.75. Here you can see 21.25 multiplied with 2, 20 plus 1.25 multiplied with 2, it's a 22.5. Here also you will get minus 22.5. Here is 0. 22.5. So what is that? It's 22.94. So or more, or you can do the iterations. somewhat if you do 1 again, you will get almost. Okay, that's it. You can reduce the kinematic indeterminacy. You can reduce the kinematic indeterminacy by applying by eliminating the far end. Are understood? By eliminating the far end, you will get directly. So no need of doing the so much iteration process unnecessarily. What is that? Unnecessarily you will do those things. Just delete it. Okay, just delete those things. You will be free. Okay, that's it. That's it. That's the good idea. Okay, that's the good idea. Okay, that's it. Now we will take care of another type of problems. Another type of problem is, okay, I will do this. Another type of problem: if any support sinks, one of the support is sink, we will do the problem. See how much easy this is. So you can eliminate any hinge joints at the outer ends. If you can't eliminate, you will do these many iterations. Okay, because you just increase one extra kinematic indeterminacy, it's going to be somewhat large. Just delete it and you will do it. You can reduce the kinematic indeterminacy. That is the kill point. Okay, understood? Got the idea? So I just delete it. I won't do this, but for that someone may arise a doubt. Okay, that's why I did this problem. Okay, so if this one of the support is sink, see, same problem, not the same problem. I will do this. 100 kilonewton motor. Okay, it's a 12 kilonewton meter. It's a 4 meters. It's a 4 meters. A, B, C. Find the final end moments. Final end moments if support B is sink by 1 mm. The support B is sink by 1 mm. Take EI as 48,000 kilonewton meter square. That's it. What we will do in what we did in a moment distribution method, same we are doing here also. In a moment distribution, what you did, just in the fixed end moments only, we taken the moments developed by the support settlements also. See the support, what is the C, what is MAB? MAB you already know. If the concentrated moment is acting exactly, if you take this is a 2, it's a 2 exactly center, what will happen? Just see it there. If you remember it, or if you taken just a center, if it goes to what will happen? It will goes like a, it will rotate like this. So for this, the moment is generated here, the moment is generated here. If those are the fixed, if those are the hinge joints, it will rotate like this. If we want to fix those, we want to generate an opposite moment. Otherwise, if it is a fixed moment, the moment is generated in this direction. What is that value? If it is m, it is m by 4, it is m by 4. You already know it. No need to remember this, what is positive, what is negative. If you know the displacement profile, you can easily say it. So I don't want to ask you to remember this is plus m by 4, that's plus. So if you see, both are clockwise, so you will get this is m by 4, this is also m by 4. Don't remember those silly things. Okay, everything in this is like a reality. Okay, so that's it. See, what is MAB? MAB, it's a 100 by 4, 100 by 4, what is that value? It's a 25, it's a plus 25. MBA also plus 25. So now see MCB, see MBC. MBC is WL square by 12. You already know it. So what is this value? This value is minus 16. MCB is plus 16. But if the support is settled by 1 mm, the B support is settled by 1 mm, what will happen? Extra moments will generate. How it is generated? If you see, taken as only just AB. Just taken as AB. Just taken as AB. How it is settled? If it is A, B, if the support is settled by 1 mm, support is settled by 1 mm, what will happen? These are all I explained number of times, but I want to explain again and again. What will happen? This will go like this. The moment is generated by in this direction, here, in this direction. That's it now. That's it. So what is that value? 6CA delta by L square. This is also 6CA delta by L square in the AB. For the BC, B is settled na? B is settled, so BC also had same effect. It has the effect. So for the BC, you see, it's a B, it's a C. B is settled. So B is settled by 1 mm. So B is settled, what will happen? So for this, it will happen. Here it will happen. That's it. Na? Here is happen. What is that value? Same. 6CA delta by L square. This is also 6CA delta by L square. So we already given EA. We already given EA. Delta also 1 mm. L also, you know, this length is 4 meters. This is also 4 meters. If the length is different, you have to calculate it. Okay. So what is this value? This value is what? So for AB, it will get anti-clockwise. See, this is anti-clockwise. This is anti-clockwise. Negative of 6CA delta by L square. What is this value? Just calculate it. I gave EA value, delta value, L square value. L also you know it. What is that value? So it's 18. It's 18. So you will get it's a 7. Okay. So here also it's, if you see, this is what? Anti-clockwise. Anti-clockwise negative. So this is also 7. Here if you see, for the BC, you will see it's a clockwise. Here it is clockwise. Clockwise you will get plus. This value also same 18 because the length is same. If length is change, you will get different value. So it is a plus 18. It's a plus 18. What is this value? This value is plus 2. This value is plus 34. You will directly take into those values considered into the fixed end moments developed by the support settlements. I explained this thing is number of times, almost 20 times, 30 times. Okay, don't need to remember positive or negative, negative or positive. Just by the deflection profile you will take it as. Okay, I already explained, otherwise I will show. If it is C, those are the not fixed end moment, not fixed ends, it will goes to like this. That's it. Na? So it is a fixed. To minimize this rotation, movement will generate. That's it. Na? That is the idea. It is a fixed. There is no rotation. To eliminate that rotation, the movements is generated in the upward direction. That's why this direction will come. Here also, if you see, it will take like this. So it is the rotation. It is the rotation. So to eliminate that rotation, it will come like this. Sir, if it is like moment is rise, someone has doubt why it is not this. If it is not this, the member is goes to like this. This is there chance? Member is goes to this direction? No. Okay, the continuity. Okay, no need. I explained numeric so many times. Okay, just delete it. So that's it. Now you can do the problem as a regularly. So if you see directly, you can see has A is fixed, C is fixed. So rotation contributions distribute. So what is that value? Distribution factor is off and off because both are the length is 4 meters. and A and C are fixed, so you will get off and off. So automatically rotation contribution factors for B joint will become off, off. So BC, BA and BC. Okay, minus 1 by 4, minus 1 by 4. You will get it. No need to do it because exactly same. So I want to explain how we have to do the problems when any support is settlement. So it's not a new thing, just we have to find out the extra moments generated by the support settlement, just add those moments to the fixed end moments. But I want to give a, if any concentrated moment is acting, that's why I include this some that matter into also this problem. Okay, that's why I choose this problem. Okay, that's it, directly take it. I will do the problem. don't let don't ask, let you do. It's minus 1 by 4, minus 1 by 4. So see, this is plus 7, plus 7. Both are plus if any concentrated moment is acting. Okay. It's a 2. It's a plus 34. Everything is plus. My God. Okay. So what is that value? So 7 minus 2 is 7 plus 2. Sum of the fixed end moments. Plus 7 plus 2. So you have to, it's plus 9. Okay. Plus 9. That's it. That's it, directly just one, because the rotation contribution from the A, rotation contribution from C is 0 because both are the fixed end joints. So no need to do anything, just one iteration, one value. B is A. What is that? BA rotation factor, sum of the fixed end moments, sum of the fixed end moments from A and C is 0. What is that value? From A and C is 0. That's it. So what is that value? 9 by 4. 9 by 4, it's 2.25. It's a 2.25. Same here also. Here also same value. It's also 2.25. MBC also 2.25. Okay, 2.25. That's enough. That's enough. Very easy. Now you can see 7. Its own contribution is 0. So previous contribution is from far end 7 by 2.5. What is that value? 7 minus 2.25. So 4.75. 4.75 plus here you can directly multiply with 2. 2.25 multiply with 2, answer minus 7. It's minus 2.5. Okay, minus 2.5. So not, it's a plus 2.5. Foreign contribution is 0. Okay, foreign contribution is 0. Here also you will get, here what you will get, 2.25 multiply with 2, you can directly multiply with 2, is 4.5, answer minus 2, minus 2.5. No need to calculate it because both are should be equal. Otherwise, what something you did a mistake. Here, so plus 34, plus 34. Own contribution is 0. Previous foreign contribution 2.25. 34 minus 2.25 minus 31.75. Sorry, plus 31.37. Okay, that's the thing. The bending moment diagram, distribution diagram, those things are prepared by you. I don't want to give a. So see, every problem is end by when I said once again, try to draw bending moment diagram and shear force diagram. Finally, a deflection profile also. If you know the rotations, if you don't know the rotations, try to do, but you can't exactly. If you know the deflections, so clockwise rotations. So exactly, if you know the rotations only, you can draw exact way. Otherwise, you can just try it. You just try it, okay? You just try it. That's the thing. Na? That's the end of the thing. Those are the fixed end moments. Okay. Oh, you can draw bending moment diagram, shear force diagram, and deflection profile diagram. That's the end of the problem. I drawn so many problems. Okay. So you can, once you know the final end moments, you can draw free body diagrams. Based on the free body diagrams, you can find out the shear force diagrams. Okay, I tried so many problems. Just at least now now you can try it. That's the end of the story. If you have any doubts, ask me. I planned today completed this those overhang beams also, but I couldn't it because some phone calls. Okay. Next class we tried to solve overhanging beams and frames also. For the next week we have to complete this chapter. So once you came back to the college, we will start the second unit. Okay, that's it.